Hey guys, welcome back to the shop. In today's video, I would like to get our new vise handle completed. In the previous video, we set this piece of material up. This is some 440C stainless steel, and we did our turning and threading on the ends there. Got that done. And so now we're going to move on to the last phase of the vise handle, which is going to be the ball ends. All right. So for this, I'm just kind of replicating, the original vise handle here. This is what comes in the hardtail vise. And one end of this handle is turned and threaded just like we did, all right, except I went with half 20 threads. And then this one ball is made to, it's manufactured with some threads there so that it'll screw together, and they use some Loctite. And that may be what we do as well, but we're gonna just replicate this. So this is what we're gonna be doing. Only I decided to up the diameter. I went with 1¼ inch and of course stainless steel. All right, so to start this job, what I would like to do, I got some soft jaws right here. I ordered a set from the Monster Jaws, so I got a couple pairs of these ready to go for some whatever work that we have that we can use it for. And so I've got these two jaws right here. I got them marked with the top anyway. First phase of the project, we'll set these guys up in the CNC, and we're gonna machine a sphere pocket in there so that once these jaws are bolted in the vise, we should be able to capture this ball bearing, or the stainless steel ball. It's not a bearing. I keep saying that because it looks like a ball bearing. But hopefully these soft jaws will capture the stainless steel and hold it so that we can then do our machining on the ball itself. So it should be captured in there like that in a pocket, and it'll be sticking up just enough we can get in there and do our machining. So that's going to be the first phase of the machining right there. And then once that's done, of course, we'll set it up and we'll begin that. To do the pocket on the jaws, this is a helical 3-flute 1/2 inch ball mill. And we've got one simple operation where once we find the work offset, it'll come in here and it's just going to use a spiral pattern and just mill out that pocket. We'll pull one out, set the other one in there, and get both of those done. And then we'll go ahead and set up the jaws, get our work offset located, and once we get on the balls itself, like I said, we're going to copy that. So we'll use a flat end mill, come in there and mill that flat. I'm going to spot it, drill it tap size, which is 29/64 for a half 20. And for the threading, instead of tapping it, we're going to go ahead and thread mill it. So this is a new thread mill. It's from Walter Tools. This one is designed for a half 20 or a 20 pitch thread, so 20 threads per inch. And I haven't used this type of thread mill yet. It's solid carbide, and hopefully it's going to work pretty good. This kind of stuff makes me really nervous, but if everything's correct, we should be able to come in here in that hole and cut those threads in that ball there. So that's the plans for that guy. All right, I've also got this go no-go gauge that we can use to check our thread. And chances are it's going to be tight going in there the first time. And if that's the case, we're going to be able to just rerun the thread mill program all by itself. Just make one more pass in there, maybe bump it over 1/1000th at a time until we can get our go gauge to screw in there like it's supposed to. So that's the plan there anyway. So I think what we'll do to start off, we'll go ahead and we'll go to the computer. I'll give you a quick rundown of what the programs are going to look like. And after that, we're going to go get this set up in the Milltronics toolroom mill and get started on this job. All right, guys, I'm going to give you a quick rundown in our Fusion 360 and show you what we're going to be doing here. So as mentioned before, we've got two setups. First setup is going to be machining the two soft jaws for our sphere. And then the second setup will be machining the sphere itself. Okay, so we'll start with setup 1, which is going to be the soft jaws. We'll go ahead and activate that there. All right, and then this is just, this is in the orientation, obviously, that it's going to be sitting in for the machining, sitting in the vise. So we can turn off, let's see, it's body 2. All right, simple operation here. We're going to use a spiral pattern. So we'll go ahead and simulate this so you can see it. This is going to be this is the 1/2 inch 3-flute ball end mill that we're going to be using to machine this. All right, so spiral pattern, I've got it set at a 10,000 step over, so it's a constant engagement of 10,000ths, and it's just going to spiral all the way down to the bottom of that pocket and just get it all machined in one setup right there. All right, so we'll speed this up a little bit more. You can see it's going to go down and hopefully just machine a nice, clean, even pocket all the way to the bottom. Just like that. And then hopefully once this is completed, we'll have a nice pocket for our stainless steel ball to set in. So once this is done, we'll take this one out. I'm going to go ahead and we'll set up a work stop here. These jaws measure, I just use calipers. I haven't measured them with any kind of micrometer or anything, but the Vise jaws seem to be very, very close tolerance to each other. You know, I'd say within 1/1000th of an inch. So I feel pretty good about just simply using a work stop on one end, taking one jaw out, slide the other one in, and hit cycle start and get the second one milled. All right. So that's setup one. We'll go ahead and transition to setup two, which is going to be machining the balls. All right. This is what it should look like set up. And we'll go ahead and simulate this one next. Let's see, simulate. And I'm going to slow this down a little bit. All right, first setup, we're going to be using a 1/2 inch diameter 6 flute end mill. This is one that I've had that's worked really well. It's that IMCO power feed. And we're using an adaptive tool path here to come in and mill this. Let me zoom in so you can see it a little bit better. Speed it up a little bit. Just get it done in one pass there, and I left 10,000ths, and we'll repeat that. We'll come in there with another adaptive and just clean that up. All right, and then the next one there, after we mill the top, this is going to be a spot drill, just to drill a spot in the center. All right, there you go. And then the next cutter is this guy. This is our drill, 29/64, which is tap size for a 1/2 20 thread. All right, and the next one, we're going to be coming in here with chamfer. Cut the chamfer, and then the last tool, you can see this is going to be our thread mill. All right, I've got it set to 3 passes at depth, and then it's going to have a spring pass to come in there and clean it up. And as mentioned before, we can post out just this thread mill operation, and I can come in there and make one pass at a time, you know, bump it out 1/1000th or 2 as we need until we get our go gauge to fit in there just like it's supposed to. All right, and then this last program, we're going to be using a 1/4 inch diameter ball end mill, and we're going to just use the 3D burr, and we're going to just break that edge. Just break the edge. I've got it set to 5/1000ths and clean that outside edge up right there. All right, and that's it. That's the end of the program. So I'm ready to see how this is going to work. I've got 4 of the machines, so I think what I'd like to do is go ahead and we're going to show you machining the soft jaws. Once that is done, I'm going to set one of these balls in there and run through the program and make sure everything is working correctly. And then hopefully that's going to work out fine. Then we'll have 3 more, and I'm going to try to get some good video to share with you of machining the balls at that point. All right, so I'll meet you out at the mill. Okay, this is the vise we're going to use. I've got it all clean. We've got a set of parallels in there, and we're using our Edge Technology parallel separator, and we're going to use their work stop right here as well. All right, so let's get a jaw in there. There's a little ding right on that corner, so we're just gonna just hang it off just a little bit like that. Put that in there, and what I like to do is I like to get the work stop. We're gonna go ahead and loosen this guy up. Get our work stop positioned where we need to, about like that. Get it tight, and then go ahead and loosen up the workpiece again and slide it up to it and retighten. All right, next up is our probe op, and go ahead and get this thing centered up. I was planning to tap these down. Yeah, that's good. All right. We've got the Renishaw loaded up. We're going to go ahead and get this probed. So this is going to be, I'm going to set this as a G56, both for the soft jaw, and then once we get them bolted on and find the center of the ball, I'm going to set that as a G56. I'm still using both of these vices for a current prototyping job. This one is G54, this one's G55, and I didn't want to mess up the work locations for those work offsets. So anything we're doing now on until I'm finished with my prototyping, we'll use some different work offsets, you know, so such as G56. Also, all the tools we're going to use for milling the soft jaws and the balls, I'm going to hand load those tools. The reason being is that I've got the whole tool carousel over here loaded up with tools that I'm still currently using. I don't want to get myself mixed up by taking these tools out and having them put back in. So I just simply have all of my tools laying over on the table, numbered, so I know exactly which tool I need to grab. And between each program, we'll just take that tool out and stick the next one in and keep going. So saying that, soft jaw is going to be X, Y in the center, and Z is going to be off the top of the workpiece there. Okay, we got our workpiece probe now for G56. Go ahead and gently, this is one of the things that I practice. When I'm done with the probe op, I slow the rapid down to usually 50%, and I move it very slow to make sure that I'm going in the right direction. All you got to do is smash that probe one time, and you'll teach yourself to slow down a little bit and not be in a hurry. So I know that I'm going up safely out of the way, bring it back up to 100%. And then we can go ahead and take this guy out, and I go straight to the cabinet where this is protected. Here's a look at our tools that we're going to be using for the job today. Got them starting at 24, go up to 29 with the exception of 18, which is a tool that I've already been using. It's just a chamfer mill. But we have our flat end mill, 1/2 inch, ball mill here, spot drill, 29/64 drill, thread milling, another 1/4 inch ball mill there, and then of course the chamfer. So just want to show you the tools that we're going to be using up. So the first one will be tool number 25. We'll get that loaded up and I'm going to test it and see if it's cutting in the right place, and then we'll start machining this aluminum. We should be ready to run. I verified the tool it looked like it was right on Z0 on the top of that workpiece. I moved it up 2 inches, did an air cut. Everything's looking pretty good. And we're going to go for it now. Adjusted our Z back down to our 0. And I'm going to use a small amount of flood coolant on this to help lubricate the cutter there, but I'm going to try my best to get it to where it doesn't splash so bad, so you guys can see a little bit what's going on. So we'll go ahead and start here and see what we can do. I'm going to bring it down a little slow, and then once it's cutting, we'll bring it in to full 100% send. Here we go. Bring it down slow, make sure the coolant's touching it like it needs to. Running 8,000 RPM. All right, let me bring it down nice and slow, down to my 0 point. There's our clearance 200. I think that's pretty good right there. Let's go for it. Here's 50%. It's cutting. I'm gonna go 100% now. I gotta say that I think it went pretty well. No crashes. Everything seemed to work. Cutter did a good job. Let me get a towel. I'm gonna try to blow this off a little bit. Let's look at that surface finish. It looks like it did a good job. It feels nice and even. Let me go grab one of the bearing or the balls and we'll test fit it. All right, there's one of the balls. Fits in there beautifully. Just like it's supposed to. All right, we'll get this cleaned up, swap the jaw out for the second one and keep going. One jaw down, we'll go ahead and just wipe these jaws out. Well, I can tell that it's touching. There's friction there. We'll leave it just like that. And I'll see if I can get you a little bit better video of the ball milling this time. All right, there's our two jaws. You guys can see them there, I think. It looks good. Yeah, that looks good. I think that should do the job right there. Awesome. Okay, well, we'll go ahead. I'm going to get the vise cleaned up, and we're going to get these guys bolted on. All right, so we just need to go ahead and take all this stuff, break this down. I'll loosen this guy and just pull this rod back out of the way, like that. Parallel separator out, and a couple parallels. Okay, there's our first jaw. Let's see if our bolts are going to work. There we go. Yeah, this moving jaw is always kind of in the way. I think it might be safe to, we'll put our bolts in here, leave them loose, and then tighten it up with the ball in there. Just leave it just barely loose. Tighten it up, that way they'll kind of, both jaws should center, hopefully. There's the air cutting off. So the air runs through the spindle on the Milltronics here for, I believe it's 15 minutes. It's either 10 or 15 minutes to help continue cooling the spindle. So that's why when we're in between machining, you may hear that air kind of going through that spindle there. It would help if it would go in. There we go. Okay, both of them are just slightly loose. And we'll go ahead and put one of our balls in here. All right, well that ain't gonna work because I can't get the wrench in there to tighten it up, can I? Yep. All right, so I was getting ahead of myself. Let me try it another way. Since we've got it, that's pretty well centered. I don't know if it'll stay, but I'm just gonna back it out there. I think the second time it worked good. What I did was I just very slightly tightened up these two bolts on this side rear. I mean, just very slightly, just enough so when I back up and I'm moving, you know, putting a wrench in there, it's not trying to move it one way or the other. And I think that worked good. So I snugged them lightly. I brought the jaw in there with the ball in place and snugged up the vise, backed it out, and then went ahead and torqued the two bolts down fully. And now when I line this up in there, it seems like it's lining up absolutely perfect. So it was shifted off to one side just ever so slightly, a few thousandths. So I like that. I like the way this is feeling, and I think we're ready to move on to the next phase. So next up, we need to get our probe and find our center of the ball there. And then our Z is actually going to be off the top of the jaw. That's how we designed it in Fusion. So this surface right here will be our Z0, and everything sticking above is what's going to be machined off. There will be a little bit of material left on top of the ball, so we're not going to be milling into the aluminum. It'll be just above that. I went ahead and ran through that first probe op just to make sure I could get my dimensions where it needed to be. But what I'm using is the Boss probe operation with a 1-inch diameter, just because we're on the top of it. It's not going all the way down to the center. G56 and an X and Y at 0 and I'm using the optional probing depth at negative 0.4 inches. And that little formula worked really well. So we'll set the camera up so you can see what it looks like probing that. All right, the boss operation for our probe worked really well to find the center of the ball. And then, so we're gonna go ahead and do a single surface Z, the top of the jaw there being our Z0. Okay, well, I've got the first one machined. I did this off camera because, as I said, I gotta focus on everything and make sure we don't have any major crashes in the process. Everything worked great, and we have a beautiful part there, exactly as we designed. But I did mess up one thing. I made a mistake. So here's our go, no-go gauge. And if I take the no-go, you can see that it screws right on down inside there with quite a bit of, slack in there too. So it's very obvious that I cut the half 20 threads oversized, the diameter. I cut it oversized. We'll put the go side in there and I'll show you just how loose it is. And I figured out what I did wrong. I'll tell you. So you can see how loose it is. And with the no-go going in there, that is a no-go part. That is a conversation piece for the desk right there. But that's why I got 4 of them. We got 3 more there to do. So what I did is I did not have the diameter of our Walter thread mill correct in Fusion in my tool library. Now when I installed this, I used the Renishaw to touch it off and do the diameter. So that is tool number 28. And you can see the diameter there. Actual diameter is 0.3692. That is what the machine measured the diameter of this thread mill at. In my Fusion tool library, when I was building this program to do this, I didn't have a cutter, so I just took one out of the Fusion library, and I can't remember which brand that was, but anyway, they had one in there that I used, and the diameter for that thread mill that I was borrowing to get the program written was 0.35. I forgot to change that diameter to this actual diameter of the tool that I was using, and that should be the problem. So it thought that this tool was 0.35, and in fact it was 0.369, so that's why it's cutting a bigger diameter hole in there. So I have modified the program, edited my tool, I have got it re-uploaded into the computer here, and we're gonna go ahead and put another ball in there, and we'll go ahead and cut it again. I'll get some video this time to share with you on how it went. Everything worked really well. The milling, the drill, thread mill, everything is working great. So let's put another one in and machine our second one. Other than the threads being oversized, it looks beautiful. Real happy with the machining of that guy. So let's grab the second one. Okay, ready to cut. All right, let's run through this second one. We got the GoPro set up. I'm gonna try to get you some better video on these next 3, okay? So just bear with me. And again, this is all manual tool change on all these tools here. And I shut off this other work light because it just seems like it always blows out everything right on top of the vise and it's harder to see it. All right, so we're gonna take this one out. It wants number 24. This is why I've been putting these labels on all my tools. This is a temporary thing, so like after this job, these will get peeled off and I won't worry about this tool number again. All right. And I will have to adjust my coolant a little bit here and there. Okay. This is making a 10,000th cleanup pass on that face. All right, so we'll do a manual tool change. Okay. Going to tool number 26. It's going to be our spot drill. Tool reset, cycle start. Thirty thousandths deep. All right. Tool number 27. This would be our 29/64 Chicago Latrobe. That's a cobalt split point drill that we're using. I'm going to go ahead and adjust my coolant while I'm here. Try not to let it sling all over the camera. Tool reset, cycle start. All right. Okay, drill's coming out. It's doing good. Doing good. All right. Next tool, number 18. That's going to be our 1/2-inch diameter chamfer mill. Tool reset. All right. I'm just watching the screen. Whenever it says to change tool, it's when I reach in there. All right, tool 28. This is going to be our thread mill right here. I hope we have better luck this time. I'm going to walk it in there a little slower just to get it started. This makes me really nervous. All right, I'm going to adjust this coolant a little bit. Try to get some coolant up in there. All right. Caser just kicked on. All right, there's 100%. A little bit more coolant, just trying to get it down in the hole there. This will be the third pass, and then it will make a spring pass. There's our spring pass. By the way, I know the coolant looks a little brownish on video. That is the lighting that I'm using. I've got warm lighting in my auxiliary lights. That's why it makes it look like it's not so good, but the coolant's fine. It's just the light making it look a little dark. If you turn that light on, you can see how much whiter it looks right there in the center, but it blows the video out. Okay, we got one tool left. I'm just going to go ahead and finish this before we check it, since we're in the program. So last tool, 1/4 inch diameter ball mill 4 flute, and that is for a 3D deburr along that edge where we milled it. It's a 5/1000. And the one thing that I forgot to do also is readjust my Y home. I want it where it comes straight out here to me. So let me move it over out of the way a little bit. Let's go ahead and inspect it. Go gauge. Might be a little tight. It doesn't feel like it's starting straight. All right, I think our pitch diameter is a little bit too small. That's what I was hoping for. I actually set that so that the large diameter should finish out at exactly 0.5, and the plan is to go in here and cut it just like we did. This was supposed to be like number 1, and if the gauge is a little bit tight, which I thought it might be, I'm just going to rerun. Dang it. I'm just going to rerun the finish pass on the thread mill cycle, but I'm going to have it adjusted 2/1000 out. So we should be able to come back in there, pick up that thread, make one pass, and cut another 2/1000 out of it, and then we'll check it again with the gauge. So this is the correction that I took with the thread mill, and this is what Kevin over Mechanical Advantage showed me to do. An easy way to go back in there and recut the thread using a thread mill. All right, this is the actual thread mill cycle right here that I have highlighted in blue. And if we go to edit that, and over here on the passes tab, we have our pitch diameter offset set to 0.047 inches, and that should bring it out to your 0.5 diameter. All right, multiple passes of 3 with a repeat finish pass. All right, so the 0.047 is the diameter that we started with. I'm going to cancel that. And what we did is we just copied the same exact program and pasted it. We just duplicated, I'm sorry, we duplicated it. So that's the next one underneath here. And I had it suppressed the first time. Now I've unsuppressed it, and we'll go back in here and we'll go to edit. And on the passes tab, on the pitch diameter offset right here, I've got it at 0.049, so 0.002 larger than the previous. All right, and it's just going to make one pass because I don't have multiple passes selected, and I don't have a finish pass selected either. So it should drop in and make one pass up, but move out an additional 0.002 from the last finish pass. So we'll just try, cutting 0.002 at a time. If I do this and it's tight, I'll come back in here and I'll adjust this, maybe another 0.002 up to, 0.051. All right, so I've already got this saved. I've already got it posted on my thumb drive. We're gonna go ahead and eject that one now. And I'm gonna go install this in the computer, and we'll try running this, this program one more time. Okay, we got it loaded and we're ready to run. Going back with our thread mill, tool 28. Tool reset, cycle start. I'm just walking it in nice and slow. I'm still nervous. Okay, looks like it's working. I did not fix that because There was a good chance I was going to have to go and adjust this again. And I forgot. Yeah, it's still acting a little bit tight, so I'm going to have to bump this out again. Let's take another 2,000. I'm just doing 2,000ths at a time until we get there. I just don't know how much to take out each pass without overshooting it, so I just feel better playing it safe. Once we have it ready to go, it's there. We won't have to, I'll have that number in the program and it should be good to go. Looks like we're finally there. Maybe not, it's getting tight. It's trying to go in there, but I can tell that's too tight. Let's go ahead and take another 2,000 pass. I think we might have it once we do that. So one more pass in there. Now, if this works out, I'm going to go back to our original thread mill in the very first tool path that we made, and I'm going to adjust that to the diameter that we ended up on our copy program. This is going to be the one. I think this is going to be good. Going all the way in there. There's the bottom of the thread anyway. Let's try the no-go side. Make sure it does not go in there. All right, it gets tight. All right, I think we did good right there. So our go side fits just like it should. We're right in the middle of it. Everything looks good. Everything looks good. That one is finished up. Now we can go ahead and put our other two in there and maybe get a couple more close-up vids of the machining action. I'm going to go modify my original program for the thread mill so I don't forget it. Take care of that, and then we'll finish this job. Okay, I've got my final program modified and saved in the computer here. But here is the handle that we turned and thread in the last video. So let's go ahead and see if it screws in. That feels good. There it is. All right, good. We'll go ahead and check the other side. That one's got a little bit more clearance than this other side there, but that's going to be fine. There we go. Okay. All right, I feel good. We finally got some progress. We got a proven program that is now working. So we're going to move on and get the last two machined. All right, guys, that was workpiece number 3. I made some changes to some of the cutting programs there. The thread mill, I was able to go onto the Walter site and put in information. I was able to get some good feed and speed info for the 316 stainless is what we're cutting. And so I bumped that up. You might have noticed in the last clip, we're actually moving through there quite a bit faster. A higher surface speed, and instead of 1.5 thousandths per tooth, I upped it to 2.5 thousandths per tooth. It was actually recommended up to 4 thousandths per tooth. I thought that was a little aggressive, especially since I haven't done much thread milling, but it did it awesome. It did a great job. Let's get our go gauge and go ahead and check it, because I haven't actually checked that yet. This is the first one after we modified our thread depth and got it right. So let's see where we're at now. Is it gonna go? Yes. Going in there. That's actually got a better fit than the previous, probably because we ran through there so many times. In fact, it's acting like it's wanting to hang up there. There's probably a chip in the thread, you know, a small chip. Let me get my other air nozzle and see if we can blow that hole out better than I did. See if that makes any difference on our gauge. It went most of the way down in there, so I think we're good. It's so close. I don't think I want to mess with it though. In fact, you know, we're just making these parts for ourselves. So let me get the actual vise handle over here. I'm just unscrewing the one that we've already got on there. And let's check it with the actual part that's going to be threaded in here. It's close. That is really close. If that'll screw on there, I don't think I want to mess with recutting it. I'm going to flip it over though. Let's try the other side. One side was a little bit more loose than the other. All right, so this is the looser side right there. All right, that is a good fit. We know we're good to go. I'm real happy with that. So we got one more. We got one more here to machine. So let's put that in there. I think I'll set my other camera up again at a different angle, try to get you a different shot this time, and run through this last one and finish up this job. I'm really excited to finally get to this stage. We now have our new vise handle complete. Balls are complete. This spindle is ready to put together and put back in the vise. So before we put this in there, I wanted to back up for a second here and mention I do have the new spring. In the last video when I was going to install this, this is the spring that came with the original spindle, and I didn't check it beforehand. It would not slide over the 1¼ inch diameter there. So I actually got on McMaster-Carr's website and I found this exact spring, and the next size up is the one that I bought. A little bit larger on the ID there, and the only major difference honestly is the compression rate. The wire diameter is slightly larger than the one that came originally. So we finally have a spring on there. That's going to work really good. We've already got one of our thrust bearings on there. Okay, so I wanted to point that out. So we've got our square O-rings right there that we're going to use. I don't think I'm going to go with the round O-rings. I think the square is going to look and function better on this. So let's get this in there because I haven't even seen it installed yet. So let's put an O-ring on here, and I'll show you how I came up with the diameter of the flats on the balls. So if we screw this together here and slide that square O-ring down, if you look closely, you'll see that the OD of the square O-ring actually matches that flange diameter there that we milled on the ball. So what I did was I measured the OD. I think it was 1 inch. Got some calipers right here. I think it was like 1 inch. Yeah, so about 1 inch in diameter, which is the diameter that I modeled this to, this milled surface. All right, so I wanted to point that out. So the square O-ring looks like it's fitting on there nicely, and it's tight enough there because I went with a 3/4 ID. This is a 3/4 rod, that it will stay in place. It should not slide up and down. Now, if it gets you know, a little bit of age, it may stretch out. We might replace it, but we'll just have to see. So let's put it in here and see what it looks like completed. Get that O-ring on and get the last ball on here. There we have it. Man, I'm happy with it. Yeah, I think that's gonna fit nicely. Remember, we got a little bit of a flat milled on there too. It would have been, if I would have thought about that, maybe we could have milled this flat to match that diameter as well, but no big deal. I think it still looks good. That's just kind of nitpicking at that point. I'm real happy with it. What do you think? Do you like that? You like the way it looks? I like the feel of the larger ball in the hand there instead of the smaller one on the original vise. You see the difference there. So the original, let's just measure it and see. I know it's, so it's 1 inch in diameter, and I went with 1¼ inch diameter on the ball ends. So like I said, I'm real happy with it. I think it looks pretty good. I did see a couple of comments on the video where we bored the precision hole in there, that there's people telling me that this is not going to work because as soon as you get some dust or material, you know, grit on here, it's going to gall it up and it's going to get stuck. No, it's not. It's going to be just fine. This is going to work just fine. I know other guys, Alex Brown is a great example. He's done this a bunch, so only he repairs old vices. So he'll take the meatball and he bores it out and he machines a bronze bushing, presses it in there, and then after he presses the bushing in, he goes through there with his boring head and he bores the bushing out to a precise fit, like a gauge fit on the handle. So I kind of took his idea on how he rebuilds his old vices, and I wanted to do the same thing with mine. So you know, the inspiration on such a precise fit on this come from Alex Brown, Caveman Welder. He's over on Instagram, by the way. So anyway, that's that. I think it's going to work just fine. We're not going to have any problems with this, you know, galling up or getting caught up in there. Keep in mind, what I'm doing, this whole project with the spindle and everything we've done on that vise, this is a project. This has been a shop project going on for, I don't know, we've been working on it almost a couple years now, I think. It's not a vise that I plan on putting in the service, any kind of hard work. We've got other vices to do that. This is something that when I'm not having to work and do jobs and repairs and do stuff for other folks, I like to try to enjoy my shop The same way that somebody might go out on the weekend and enjoy their boat or their motorcycle or go out into the woods, I enjoy my shop, my machines and my tools, and that's what I invest my extra money in. And when I have the time, I like being in my shop, playing on the machines, playing with the tools, and making stuff, creating. I like machine work. This is what I'm enjoying. And I am having a lot of fun and enjoyment learning CNC machining. I'm leaning into it. I'm trying to learn all I can so that I have new skills to keep moving forward with. And I hope that if everything works out right, I can kind of step into a little bit of manufacturing here in the shop. That's a goal that I'm trying to reach, and we have a long way to go. We're working at that. So that's some stuff that's coming pretty soon. We're going to talk about that in another video, but it just kind of, I don't know, I just wanted to kind of mention that, why I like doing projects like this. I like enjoying my shop. I enjoy using the machines that I've invested in. I got a lot of money, a lot of time invested in this stuff. So making projects for yourself for fun, that's all part of it. And I'm looking forward to having this vise completed, put together, painted, and ready to go. Nice conversation piece for the shop.